All right, so we'll go ahead and get started. Thank you all for joining. It's our I guess technically like our second or third monthly tech talk that we've been having around DevOps. In our last meeting, we talked a lot about wanting to do a deep dive into OpenShift and wanting to get into like some live demonstrations to kind of get more visibility into the product and a little bit more understanding of the use case. With that, I'll turn it over to John Matthew, who is the head of our cloud practice group, and he'll walk us through the information today and give us a wonderful demo. Any questions or something like that you have, if you need to ask him during the time period, especially in the demo, don't be, I think John's okay with you interrupting him, or if you want to wait to the end and ask your questions, that's fine as well. Thank you all for attending.
Good morning, everybody. Andre, thank you very much. Again, John Matthew, Red 8, Cloud and Automation guy. So again, thanks for everybody being here. We had a really good meeting last time. I'm going to spend most of the time in the demo moving around a lot. As you can see, I've only got 11 slides. I'm going to work on showing off OpenShift. It's very interactive. And if you have questions about what's going on, please don't hesitate to stop me or ask questions. I've got a quick little agenda here. Number one, everybody see my screen okay and I sound okay?
Yes, sound good.
Yeah.
Excellent. So last we left, we talked about a couple things that both infrastructure and developers were looking for. We'll cover that. We'll cover a brief 2 slides on OpenShift and its architecture. These are marketing slides from Red Hat I stole. We'll talk about some of the developer benefits and the infrastructure benefits. And we're going to, again, I'll have an agenda for what the demo entails. And then we'll talk about what we think, would be good for Honda and then maybe some next steps. So last we talked, and this is not uncommon at all, what I got away from the last meeting was the developers want a quick way of spinning up projects and environments, as quick as possible. That could mean less than a day, a couple of hours, a few minutes. We'll see in OpenShift that's literally minutes. And infrastructure wants the ability to give developers those environments quickly. In a traditional model, it takes a VM, it takes a project, a ticket, some firewall, some load balancer possibly, and then on top of that, they want to make sure that the developers aren't blowing up the environment, which, again, I used to be a developer, still I am on the side, so I know what those challenges can be for both parties. So I'm a huge fan of OpenShift. I've been using it for 5 or 6 years, but back in the days of what they called OpenShift 2, which was a precursor to containers and things. So I'll kick right into it. And OpenShift was built to manage a container environment. So it's focused on the developer, but it also gives infrastructure quite a bit of information. Red Hat has always had this open source, but they do have a very nice enterprise product with lots of good features, like all of Red Hat's products. It gives you a summary here on the page of what its idea is, right? So it's not restricted to any one environment, meaning you can run it on bare metal servers, VMware, Red Hat virtualization, OpenStack, Amazon, Azure, or Google. They don't really care. Again, it runs at the container level, which is any operating system, any Red Hat operating system will run this. As we'll see, it's got a lot of these features. It has all these features, frankly. Automate operations, multi-tenant. I think that's important for a lot of businesses. And multi-tenant doesn't necessarily mean different. Honda versus, say, IBM, I think it means different business units. And we'll see that the multi-tenancy is very isolated. Again, secure by default. I'll talk one thing. I don't know if anybody follows the trades on security for containers. About a month or so ago, there was a vulnerability found in it was either Docker or Kubernetes. I think it was Docker, where somebody had proven they could break out of a container to the host operating system, which is pretty big, right? That's a big breach. However, OpenShift was not vulnerable to that, and that is because in addition to relying on both the Docker and Kubernetes security policy, they wrap their own firewall rules around every container, specifically with IP tables and some other security they do there too. Network over-the-air updates. Again, I won't get into all of these. So there is a monitoring system built into OpenShift that's really good. And the pluggable architecture, this is where Red Hat and Google essentially are driving the Kubernetes ecosystem in directions for some amazing tooling. And there's some stuff coming out in OpenShift 4.0. I'm not going to show that, but there's some really amazing stuff coming out in OpenShift 4 that's bringing this to a whole nother level. I'll pause there real quick for any questions. Okay. Again, if there's any questions along the way. So this slide here gives a brief sort of layered approach to what OpenShift looks like. Again, you've got whatever layer of OS you're going to run on whatever hardware, whether it be virtual or physical, private or in the cloud. OpenShift itself is supported on two main operating systems. There's something called Atomic Host from Red Hat, which they invented or built a few years ago. It's a minimized version. It's a immutable operating system. Pardon me. In response at the time to CoreOS, they also run it on Enterprise Linux, which is a Red Hat derivative. Since then, in OpenShift 4, they're moving to what's called CoreOS. They purchased CoreOS a few months ago, or about 6 months ago. A great operating system, so they're consolidating all those purchases into a very lean operating system that literally is built just to run containers. On top of that, you basically have in the blue section, you've got quite a bit of architecture around Kubernetes. So Kubernetes itself provides a framework for all of the above: networking, storage, a registry, log and metrics, all of those. And above that, I'm not going to go into too many of the details. CI/CD is built in. You've got some automation. As we'll see, you've got a complete service catalog, and that is, again, geared directly towards the developer. We'll see that in a second. And it's all self-service, meaning the developer doesn't need to go to infrastructure for anything to do probably 90% of their job. So, and then all of this runs within containers itself. Questions at this point? All right, silence means to move on. So a little bit more marketing here. I'm not going to read all these off, but basically, like I mentioned, OpenShift is designed to allow developers to move quickly. It's built on Kubernetes using containers, and developers want a lot of stuff, but infrastructure wants stuff too, and sometimes those two can collide. I think OpenShift is a really nice blend of the two. Again, from a developer perspective myself, there's really not a lot I can't do in the product, but at the same time, as an infrastructure person, I can limit what developers can get away with. For example, maybe I don't want you to have 16 cores on your SQL server that might need 2. Maybe I don't want you to spin out 45 front-end servers. These are the kinds of limitations that infrastructure can get away with, can do, and restrict the developers with. Or you can work, cooperatively to figure out what you need on that level. Let's see. All right, so I put some notes together about what is in OpenShift, right? So it's self-service. We'll see that in just a second. Again, runs on any platform. You'll hear the term microservices. Essentially, what a microservice is that it's a very specific application that does one thing and does it really well. Given containers and the way things are rolling, you don't need to build huge monolithic applications anymore. You can use very specific small services and then scale those out as necessary, as we'll see. Again, it's built on Kubernetes. Red Hat is the second largest contributor to Kubernetes. It was released from Google, called the Borg. Anyway, these are not terribly important background on it. Again, I mentioned it's got a CI/CD environment built in. However, it does integrate with Jenkins out of the box, no problem. So if you got Jenkins set up to run your build jobs, then you can just plug that right into OpenShift. I'm going to be using the one that comes with OpenShift. It's pretty straightforward. again, I mentioned numerous times it's built around the developer, but it provides mechanisms that the developer needs, but you don't have to get infrastructure involved. So, for example, securing an application from an infrastructure perspective can be challenging. OpenShift does it out of the box. The other thing that's something that doesn't happen a lot in environments with applications is logging as well as monitoring of an application very specific to that application. So I've been in environments where developers will build lots of good logging in their apps, but then the app, the environment doesn't have a way to capture those logs, right? So a syslog or a Splunk or something like that. We'll see that that's built in as well to OpenShift, but at the same time can be ported to something else as well. Monitoring is built in. The other part that's really nice, I think, is scalability. So the benefit of Kubernetes and containers is the fact that you've now taken environments that are inherently immutable, meaning a container is not modifiable, and you've allowed it to be scaled through Kubernetes very easily, and we'll see that as well. The other thing, too, is developers want to get access to their VMs or their containers, right? They want to make that easy. We'll see that that is very simple in OpenShift. Again, I can get into the DOS prompt or the command prompt, but I can't really do anything from that point. I mean, I can't break out and be a rogue developer and go, hack on someone else's app, which is not usually the intention. But again, we want to keep that secure. We'll talk about health checks, and as well, I can demo a version of something called MiniShift, which allows a developer to run this locally on their laptop. Covered a lot. Hoping to hear some questions. Anybody? I know it's later in the day out there in Ohio. So, all right. So, with no questions, we'll kick into a demo. My agenda for the demo is poke around OpenShift. We're going to build a quick little app I found on the internet, just some random Flask app. I'm a Python guy, so I'm comfortable in the Python space. OpenShift does support Java as well as many, many other languages. We'll take a look at the CI/CD example. We'll do some scalability and HA stuff. We'll kill some pods, as they're called, and go from there. So, again, along the way, if you guys have any questions, please let me know. Everybody see my OpenShift screen okay?
Yeah.
Okay, so in OpenShift, again, I'm not trying to minimize infrastructure's perspective here, but from a developer's perspective, this is what you get, right? I'm a developer. I'm not an admin right now. I'm just a regular developer, and I can build projects very quickly, right? I just click a button. I'll do that in a second. But at the same time, I've got existing projects that I'm working with. Now, these projects are all isolated, both from a network perspective, from a container perspective. They're all totally independent. They don't see each other. Okay, so that's again number one. Security is number one on their list. This is a pre-canned example Django app that comes with that you can download and install from the internet off of GitHub that demonstrates OpenShift using Django, which is a Python framework. It's pretty straightforward. It builds it's got a Postgres database, right? So it's a multi-tier application. It's got a database backend. It's got a Python Django front end. And on top of all that, it's got a website. It's a basic website. It doesn't really do a lot. It basically says, hey, welcome to Django on OpenShift. Although there's some misspellings up here we're going to fix in just a minute. And it gives you a little bit of data about what's going on. It's just a demo. It's just there to show you, like, hey, look at how easy this is. Now, what I want to cover, though, is what's behind all of this. So a couple things to keep in mind. There's the application itself, which is in a container. Now, in the Kubernetes space, those are called pods. Pods have they're sort of a framework themselves. I'm not going to go too deep into what pods are, but pods are sort of the atomic nature of Kubernetes, right? When you scale up things, you scale to more pods. And that's what this term is. It says I have one pod, which is the application front end, and I have another pod, which is the database side of my system. Now, again, out of the box, I've got monitoring. I've got some scalability here, right? And I've got some routing. So out of the box, from an infrastructure perspective, OpenShift has provided infrastructure with tons of things. It's provided with security. It's provided it with some monitoring. And really importantly, it's provided it with a load balancer, right? So a lot of our apps are not load balanced. I'm hoping the ones at Honda are. But if they're not, and we start porting this to a container OpenShift environment, they are by definition automatically load balanced. That's done through the router that's built into OpenShift. That right now is based on HA proxy. You can plug in to the F5 if you prefer. If you guys have F5s on premise, OpenShift works directly with the F5, meaning as I scale up my app, it will go tell the F5 or the load balancer, hey, there's another path to my front-end container. Please go ahead and use that. And again, I can go into some of the details around that. So there's lots of areas to this. Again, most of these are Kubernetes. I'm not going to go into all of these. So how many developers do we have on the phone, or development teams? Anyone?
I guess I'm considered a developer.
Okay. What do you guys develop in out there?
Java, Visual Basic.
Okay. Excellent. So some of the things that are built into OpenShift, something called secrets. So things like passwords, right? Passwords to the database, passwords to your app, passwords to anything. That's all built in here, so you don't have to put that in your code. You can, I'm not going to go into the details of how those are mapped. That's a Kubernetes idea. But you have things called config maps, which either can mount a file which has those secrets, or those can become environment variables in your pods. The other thing to consider is storage. So storage for an app can vary. So in the case of, back to the front end here, in the case of the front end for Django, I don't really need any storage per se on the front end, but my back end Postgres database would need some storage. And one of the things that Kubernetes and OpenShift provide together is the ability to map storage to this container consistently. And what I mean by that is if something should blow up on this container, the data is not lost. The database goes away, gets recreated, but it maps back to the same storage space. And again, some of these things are taken for granted. But again, if we think of it from what infrastructure provided in the past, part of that opening ticket for your application, you'd need to specify, what's on the VM. Do I need some storage? Do I need a mount point? All of those things are abstracted away with an OpenShift container environment. I mentioned monitoring. Monitoring the environment is built in to the system. So any of my pods, okay, there we go. Any of my pods are monitored, and I get to see all the things that are going on. So I've got memory usage, I've got CPU, basically anything, again, as a developer, I would need to look at to go see my application running and how well it's doing. Right now it looks pretty boring. It seems like it's working, so I like what's going on. Any questions so far? Tough crowd. Okay, so real quick, I'm going to go out and I'm going to build an app. I just want to show how simple this is. So what I've got here is I found an app on the internet based on Flask, which is another Python framework. It's built around an OpenShift Flask app. Not really sure if it's safe. It doesn't really matter, frankly, because again, OpenShift is secure. It keeps everything isolated. So I'm going to see what this looks like. First, I'm going to do OC new project. Now, the reason I do it from the command line, I just wanted to show that for those command line junkies out there, it's available. I'm going to mention, and again, I've got the website in the background. So as soon as I hit that, oops, I forgot one thing. Sorry. This is a good point to point out. All right, so one of the things is, as a developer, what it's trying to do is go to my local version of OpenShift. As a developer, I don't want to log in with my name and password from the command line every time. So what they've provided is tokens to get me onto OpenShift. So basically, I literally go and I say I want to log in from the command line. It gives me the command line with a token ID, and away we go. I'm logged in now from the command line into my OpenShift environment, which is the same as that page I've got there. So after I do that, I'll do new project Flasky, and poof, up on the background it shows up. All right, so Flasky doesn't have anything in it right now. I'm going to do some more stuff there. And I'm going to cut and paste this line. Basically what I'm telling it is I'm telling it, okay, I want you to go out to GitHub. I want you to go grab this repo. I want to call it Flasky, and I want you to start building it. These are all, and what I'm going to do is go into Flasky real quick in the back. So you see the project itself, right? Again, there's projects, applications are within a project in OpenShift. So it's really got nothing going on. There's no pods, there's nothing. But here, I'm going to tell it, I want you to go out, I want you to grab this environment, and I want you to start building it. So it's that simple. It will go out, it will clone the repo, and it will begin building it. Now that repo itself has a Docker container and a Docker file. I don't know, I didn't do anything, I did not build this app, but it basically says if I go out and grab this, I should be able to build it. And sure enough, it goes out and it begins to build that container. So now, normally, you guys have done some container work there locally, correct?
I think most people on the phone, the answer may be no.
HRA has done a little bit.
Okay.
Anna has not.
Right. So the whole container craze has taken over. Containers are awesome, and I'm a big fan of OpenShift because it takes my efforts away from having to build containers by hand. Basically, I don't need to build things by hand. So in the past, if I was doing just containers, I would need to do this step that's compiling in front of us, right? That's building in front of us. I would need to say Docker build. It would build a container. I would then need to map some ports and things like that in the Docker file. But OpenShift is built, again, around containers and Kubernetes, so it knows how to do that. So it takes that Docker file and it starts to build the environment itself. And again, I mentioned that OpenShift provides you access to everything that's going on. This is literally the console of the Docker build going on. So I can see from a logging and troubleshooting perspective everything that's happening just as I would on my terminal as a developer. So again, the idea being as a developer, I get up and running very quickly. As a person in infrastructure, I don't have to worry that they're leaving the environment or doing something crazy or breaking out of an environment that I find to be secure. So again, everything I need as developers here, everything that infrastructure wants, keeps them isolated and secure, and I can see all the time at every moment what's going on. So I can see there it's being built. This build actually is taking quite a bit of time, which is okay. That's not, again, it's based on what it's doing. So you can see it's grabbing a bunch of stuff. It's downloading it, it's compiling it, and that's about it for the build going on. Now it'll finish up in a little bit, but in the meantime, there's another premise. I mentioned the built-in router. So one of the things that my app is going to need is I'm going to need to be able to access that website, that Flask app from the web, right? And in that case, I just need to expose the application itself, and OpenShift knows, because of Docker, it knows all of the pieces of that application. So it looks like it built it, and what it has done, it has taken all of that, it has built the container that my Docker file defined, and it has made that new pod, and it has put it into what's called the registry of OpenShift. Now, the registry is not new to OpenShift. That's a Docker feature. But it is contained within OpenShift itself. It's not on the public internet. So it keeps its own registry of apps, and then it takes that pod and it pushes it out and it instantiates it inside of OpenShift. And that's what that blue pod that just appeared, that blue circle that just appeared, that basically tells me that my pod is up and running. But if you notice, there's no hyperlink to get to it, and I'm wondering how I'm going to do that. So I've got this little create route down here. I've also got this ability to say OC expose SVC Flask app. Now, if you notice, that name matches the name moniker I put up above it. I hit that, and immediately, again, it's all real time. There's no waiting. I get access to that app. Now, this app doesn't do much. As you can tell, it just dumps a bunch of JSON to the screen. But again, the point is that I took an app, and within minutes, I was able to build a Docker app up on the screen, up on here, and it's, again, isolated from the other ones, although it has all the same features. I've got all the monitoring, I've got all the logging, I've got everything I need, and I get the URL behind the load balancer. Questions?
Hey, so John, so Andre here. So from a infrastructure perspective, like I know we have application containers, right? There's networking. Was there any other infrastructure that was deployed with that, a database, or is it just strictly a web app outside of that?
That's great.
Or
great question.
How can I tell?
That's a good question, Andre. So in this case, this app itself just has a simple Flask app. This person wrote this to basically show how you can deploy, from the ground up a Docker container into OpenShift and expose it. So this one does not have a database defined, but as I mentioned before, this other app itself has a database behind it.
So how can I, so I see the deployment config, so, okay, and then I see the PostgreSQL. So you just have to know that the projects that you deployed, whatever you had in a container, one, you containerized infrastructure, it looks like it, and the other one you had that was a project around an application deployment. Is that correct?
Yeah, it really that's a good question. It depends on the application itself. So the beauty of containers in OpenShift is you can build them sort of individually. So I can say build the Django piece without having the database yet, and I can add the database later. So you can build these in pieces. And so what will happen is you'll build these again. Usually you'll start with a framework or a base file that will give you this kind of layout. And it really depends on the app itself. If, for example, I just wanted to bring this up real quick, a new project, Honda 1. So I'll make a new project just called Honda 1. And you can see from the catalog itself that comes with OpenShift, typically you're going to pick one of these and then build off of this. And all of these are on GitHub to start with. So if you have, your app is similar to, I don't know.
Gotcha. So we can build a JBoss web server. Got it.
Yeah.
Okay.
Right. And then I know you guys are WebSphere, so there's IBM has some WebSphere stuff. You can actually add to this catalog as an individual developer as well. This catalog was added for everybody to use. This instance I'm using of OpenShift is a demo instance from Red Hat. It's for those infrastructure guys. It's a 3-node, it's a 3 VM, 8x64 each VM instance that I get to use for demo purposes. So this will be destroyed in about a week. But it's a self-contained copy of OpenShift running. You can see there's just a ton of stuff that comes on here that you can utilize. Notice .NET's here as well. So Windows containers are supported. I'm not going to cover all of this. Cake is this is a PHP environment as well. So it really it is, again, it's really dependent upon the developer. So if you have an app that's just a simple Java web app, right, you could just deploy the Java web app. But if that Java web app connects to a database, you would probably have to do a little bit of re-architecting to get your stuff into a well-written container environment, if that helps at all. All right, so real quick, I do want to cover a couple of things in here that I think are important. Again, developer-centric, but again, from an infrastructure perspective, these are all the things that I think as an infrastructure guy, when I was doing it, people would ask me, I want access to my VM. Where's my logs? How do I get, how do I change the config? I need more memory, or I need more of these. All of these questions are answerable in the OpenShift world or in the container world. Fairly straightforward. So in this case, I'm going to scale that back. And I'll go into the scaling in just a minute. Let's see. So this in OpenShift, you can get right into the pod level or container level, right? So this is the container that's running. You get to see its IP, its name. All of this gets automatically assigned. Again, from a perspective of making developers, frankly, get them off your back as an infrastructure person, it's great. I see the logs directly from my app. Okay, so this is literally the console output from my container. Right, there's that. And I want to go right into the terminal of the container. Right, so I can see what's running. I can do nice top. All right, I can see that I've got a crap load of 16 by 64. Pardon my French earlier. So these VMs are 16 by 64. If you're familiar with the way Docker and containers work, they do expose the host's raw resources, but those are limitable. You can limit those. So again, there's really not much I don't have access to, right? As a developer, I look and I'm like, wow, look at that. That looks like my app. I can look at my welcome app. This is my raw code, right? This is what I wrote. So again, I get everything I need right in here. This is a Linux prompt, but this is literally just the container. I'm not on the host OS. I'm not on the VM OS. I'm literally in my container. I can't break out. I can see what my IP address is. I can probably ping Google. Yep, that's limitable as well. They let me do that. But again, I can't break out and see other stuff, right? I don't think I can sudo, can I? Nope, sudo's not installed. So again, from a infrastructure perspective and a developer perspective, they give you the best of both worlds. So I get exactly what I need to do. I can get in, I can see what's going wrong, if anything is going wrong. All right, so let me kick back into my, oops, sorry. I wanted to show a couple things. Shell logs. Okay, so we got the logs. We covered monitoring. So let me, I'm going to do a little bit more with monitoring real quick. So one of the things, again, how many infrastructure folk do we have on the phone? Anybody?
Well, I
think we're hybrid too.
Okay. So for the infrastructure folk, how many times have the developers come to you and said, my app is crashing, I need more resources? Has that ever happened? And I can't be the only one.
Rarely. We don't really do a lot of apps in R&D, so.
Okay. Anyway, I'll simulate. So I was at Warner Brothers for many years, and we had a lot of Java developers that wrote the less than efficient code, and many times their apps would blow up. And what would happen is they would number one, they wouldn't load test their apps. And when they did, they would blow up very quickly, and then they would say, well, I need 10 more VMs of my app. And I'm like, okay, well, that's going to take us a few days to recreate the VM, install your app, put it behind the load balancer, and all those things. So I use a program, for those of you familiar with Apache Bench. There's another one I found written in Go called Bombardier. And really what it does is it mimics it definitely mimics Apache Bench. All it does is sends a ton of HTTP requests to a website. That's literally all this does. So it basically says I'm gonna send 150 connections, and I'm gonna do it for 240 seconds. I'm gonna change those numbers. I don't want to wait 240 seconds. So I'm gonna take that. I'm gonna do this, and I'm gonna do 50 connections for say 30 seconds. Now, I'm going to basically hit this website, right, that's going on, and I'm going to try and load it up and see what's going on. So I can see it's a little slower, came back a little slower. Now, if you notice too, again, this is for demo purposes. This is all set up to do this kind of stuff. This number will be increasing slowly but surely. And I'm noticing that it's like not that great performance-wise. And I can see here the monitoring. So, and look at that. My container has been running for more than 5 minutes, but hasn't passed the readiness check. So again, from a infrastructure developer perspective, built into OpenShift as well are health checks, right? So one of the things that was frustrating to me as an infrastructure guy at Warner Brothers is these guys would build these apps and they would never know when they were healthy. They would not have a health check. There's 2 levels of checking in OpenShift. There's what's called a health check, and there's a liveness probe. One is, has your, let's say Java has crashed and your app is just completely dead, then that would be a liveness probe, in which case OpenShift would kill the container like it just did and said, well, you know what, let me throw that container away. Let me take a copy of it and redeploy it, and it has done that. And I did my bombing here, and I can see it didn't do too well. I'm not going to go into I was doing some research earlier as to why that was happening, but from a logging perspective, I can go in there and see the logs, what's going on. In fact, I see here on my logs, I'm getting the health check. There's a health URL endpoint that it checks to see that it comes back. Now, if I start bombing this again, we'll see that scroll on by, because what's going to happen is I'm hitting the main URL pretty quickly. So now, at the same time, let's say I want to have 4 pods in the front of that. Now, what this is doing, so this is a 2-tier app. This is a web app on the front and a database on the back. I've now just asked OpenShift to deploy 4 copies of my front end, which are just containers. Now, containers are immutable, meaning that it's a static version of the app. Deploy 4 of those, put them behind the load balancer, and they all get access to the database, and everything is fine. And again, all of this happens non-disruptively. So I can keep going here. And my app seems to be working just fine while I'm bombing it. And so I can see I got a few errors back. And as a developer, again, that's all I am. I'm not an admin on the system. I get all of this ability without having to call infrastructure to get more access to resources or any of that stuff. That includes logging, monitoring, troubleshooting, all of the above. Questions so far?
This is Keith. So I'm kind of waiting because I'm not sure where you're going to be going or ending, I guess. But I have a couple questions about I'll call it versioning and who has access to kill and create and control the app. Once it's, for instance, we'll pretend it's a production app, right?
Okay.
We may not want, especially in an enterprise, some guy going in, and especially a developer who may or may not know what's going on, and instead of 4, he puts 40 or something. You know what I mean? And that kind of stuff. There should be some sort of an authorization change, a change control. I don't know what you guys call it, but
right. So I know where you're going, and that's a great question. So a lot of that, basically what I'm hearing is we don't want developers touching production, right? You don't want you don't want a guy coming over into production and doing this. I want 0 pods on the front end, and boom, the app is down, and everybody's screwed. Or like you said, the other way around, right? They completely bury your infrastructure. So that's not in this demo per se, but what you would do, that's more of a pipeline discussion, meaning you would build a instance of your app, and this is sort of in the end of the next step. So you'd have an environment that would be production OpenShift, for example. And let me just go into, and I'll show you what I mean by that. So the the build itself. So this build, so this is the build. This is the GitHub link for this build. This repo, right, is out there. It's on my repo, but it builds from the master branch. So what you would do, to answer your question simply, is you would have production OpenShift that developers don't have access to. You would. They would hand you the deployment configs, essentially. It's a JSON file, and say, okay, deploy this to production, right? And then you would deploy the production branch, and they don't have access, right? You as infrastructure would say, okay, we're going to scale this up to X, Y, and Z. If they make a change to the code, right, you guys then, through your pipelining, would say, okay, we're going to redeploy production. And you could then, and let me demonstrate that in just a second. Is that kind of where you're going with this, Keith?
Yeah, because we've been doing some POC stuff here, and that's some of the stuff that we're building into that in that pipeline itself is our checks and balances, if you will.
Okay, good. So the other thing that's not really demonstrated here in this demo is you can, and we were building this at my last gig, was you can make it so that people can't just build any project they want, right, and start deploying. You have to go through a whole like a Jira system, right? So Jira would say, okay, I want to build a new OpenShift project. You could limit it to that. That's not really the focus, but let's assume for a second that this was production, right? And you're like, okay, so this is all messed up. What's wrong here? Welcome to your, this is the Django. Let's go fix that. So this is production, and I'm a developer, and I'm going to go fix it in production. Let me go make sure. Okay, so this is the repo that I'm building from. And I go, okay, let me see. I want to go into my welcome. And I'm getting in the weeds here, which is kind of what I wanted. It's a great question. I'll send you the 20 in the mail there, Keith. So this is the file that I want to modify. I'm a developer. Again, they wouldn't do it in GitHub, but just for sakes of demo, I'm going to edit this file. And I'm going to come down here, and I'm going to change that wording a little bit. I'm going to say, welcome to your, this is the Django. No, I don't like that. Welcome to the Honda demo for Keith Django application on OpenShift. How's that look, Keith? Look okay? So,
yeah,
all right, we'll commit that change, right? I commit that to production. We go through our testing regimen. We're very happy. We like the way that looks. And I go, you know what? Okay, let's roll that out to production. We're going to rebuild it, right? So when we rebuild it, in fact, let me just do it from up here. I'm going to say this. Start build. So what this does, this starts the CI/CD pipeline for this branch, and it's as simple as that, right? So you can say start build. And what it will do is it will literally go down and start building it. And what that means, it's going to clone out, again, it's going to go out to GitHub, it's going to cover your internal repo, it doesn't have to be GitHub. It's going to go grab the branch, and it's literally going to build the app and deploy it to this instance in OpenShift. So if this were production, this would be you. After the developer said, yes, we've passed all our tests, we're happy, we want you to redeploy production. Now you can also do what's called a blue-green deployment. That's something I'm not showing here, but you could say, okay, I'm going to roll out the green changes, and I'm going to keep it 50-50 or 20-80, whatever you want to do, and I'm going to roll that out to production. So again, the developers would not have access to the production OpenShift. They would literally just have access to the development and QA environment. Does that sort of go where you're wanting to go?
Yeah, that's it's not all of it, but it's some of it. It helps out a little bit. Thanks.
Okay. So if you notice here, the other thing I want to point out is that the idea of OpenShift is it's designed to be very non-disruptive. So it is basically rolling out this new copy of the application in a new container. And if you notice the way it's doing it here, it's pretty cool. And all of that is visual, but at the same time, it's all working with the load balancer. So what it does is it rolls out a new copy of that instance. And let's go see if it's fixed it. Hey, look at that. Hey, look, a new copy of my app. Thank you, Keith. what it does is it rolls out the pod, and then it does that liveliness check. It actually asks the pod, are you awake? Are you answering calls? And if it says yes, it tells the load balancer to swing it over. And now it's not deployed, it's not destroyed the old build. They're still there in the registry, but I'm running the new instance now. And then, again, sort of along the same lines, you have an oh-fit moment. That was with a, let's see, I have an oh no moment, right? And I go, here are my builds. You know what? Oh, look at that. I've got how long it took. I don't like what number 5 is doing. I'm going to go back to build number 4, which we know is working. And I'm going to say, where'd that go? I want to rebuild it. I want to deploy. Sorry. Where's my applications? Deployments. Let me go back here. I want to go back to deployment number 9. And I want to say, that was the one I liked. I want to roll back to that. Sure, roll back. So now, I've rolled out the Keith change, and that was bad. But now I need to go back. And again, you as production would do this. This could be automated. Again, the point here is it's all very point and clicky, which is good. And again, what it's doing is it's taking that old pod, it's checking to see it's awake. Once it becomes awake, it will scale this down and scale this up, all at the load balancer level. So in theory, if John did his job right, I should click here and this is the Django. Welcome to your, so I'm back to the old version. Did that impress anybody? Keith, anybody?
Yeah, I mean, I already know about this stuff, so.
Right.
It was when I first saw it. Yeah, it's cool.
Right. Yeah. This from a application developer production infrastructure perspective, this is huge in my book. Right. The fact that I can go back and find those old builds and see them, they're still there in the registry. Right. I've got them all out here. I should say those are deployments. These are all OpenShift training, questions. But again, you can see I've got all these back from wherever I did it. So this is a huge part. So to answer your question, Keith, though, is you would have a version of production that developers don't have access to. But you guys would all hit the same repo, right? So they would be working on different branches. Their CI/CD framework would be, and workflow would be, fixing, making sure those all work. And when they say, you know what, we push to master, we like it, let's do it. So along that same lines, I'll show one last wow factor here, and that is you can actually, from a developer perspective, you can make this all automatic. You can make this all automatic for you as a developer. So let's assume for a moment this is my dev branch, right? I'm working in dev. I'm not worried about blowing it up, and I'm going to go make a change. But I want to tell it, I want it to be automatic. I don't know if you've seen this, Keith, or not. These are called webhooks. Put in my password here real quick for GitHub. So these are webhooks, and I've got it turned off. So what a webhook is that GitHub, they didn't really invent this, but it's a great feature. Basically, whenever there's a change to the repository, it will notify OpenShift, and OpenShift will do something with that information. In this case, I want it to rebuild the app and deploy it. Now you can tell OpenShift not to do that. You can tell it to do other things. I've got this info here. Welcome to the Honda demo. Keith, I'm just not feeling the love anymore for you, so I'm going to remove your name. Please let me know if I'm moving too quick. Welcome to the demo. Welcome to the Honda demo for a Django application on OpenShift. I like that, right? So we're going to go commit, and I have to go back pretty quick. Boom. So what has happened is the webhook fired, and then OpenShift got that. It says, oh, there's a new instance, there's a new copy of the code. Let me go redeploy this. So this falls in line with your whole CI/CD pipeline. Testing is happening. It's going to rebuild it, and we're going to see the same thing happening with regards to with regards to that rolling out like it did before. Any questions? Happy to answer any questions.
So in this scenario, I guess, Keith, outside of that, talking about from an access control authorization, the workflow process would be, what are you allowing to be pushed into your release branch, potentially, if you were using the webhooks, right? Because that's what you're thinking about, how do I control that?
Well, I mean,
yeah,
in reality, we'd be doing this in Dev and QA, right? That's where our developers are building everything. And then there would be, a change authorization request to, put it in production, right? So, UAT testing, all that kind of stuff to make sure we don't blow everything up. And then once that's good, then we would, whatever process we would make that happen into prod.
Gotcha. So you're using like a build master role, and so that build master has the authority to make sure everybody is getting all their items, and then they have control over like that particular release, and they're the ones just going to move it, say, out of maybe QA into production or something like that?
Something like that, yeah.
Okay.
Yeah, we're still playing around, but we just don't want people all of a sudden changing stuff without anyone knowing, because that's disaster.
Gotcha. But in development, though, from a per instance perspective, the developers have the access as they're deploying their incremental changes.
Correct.
They can deploy those and see them in the dev environment. Okay.
Yes, absolutely.
Exactly. So the one last thing I'll bring up. Go ahead, Andre.
No, I was just going to go. I know, like Todd and Gene, you guys in Ohio, I don't think you guys had an opportunity to get into like an OpenShift environment. Keith is ahead of the process. I know the guys like in Alabama were ahead of the process a little bit as well. I think that the value of what you guys are looking at here is that, from a development process, this can be OpenShift you can use on your like on-site environment, and it's a management tool that you guys can use to deploy to have access to everything within your actually on-site dev environment that you have. So in your situation, you don't have to keep going back to whoever the infrastructure sources are to ask for those as you're doing your incremental build items. And as you release those branches or update those, I would say those incremental pieces of code in your environment, you can release those inside of your development environment and then kind of see what that, delta change, did it improve, did it do what I expected for it to do, et cetera, et cetera. And you have somewhat of a small infrastructure that you're deploying to. So a little bit different than, say that I'm doing it all on my actual workstation, which I think is a segue maybe potentially where John may be going to as well.
So the last thing I'll bring up, Andre, is the fact of resourcing. So one of the things that you can go in and specify for, there's a lot of things I'm not demoing, but basically resource limits. So I can go in here by default, and again, as an admin, I can limit these, right? I've said that the Postgres right now is limited to what's known as 500 millicores, which is essentially half a core, which for a database that does any amount of work is not a lot. But again, it gives you the idea that you can, as an infrastructure person, you can limit what the developers can get to. So there are global limits, there are per project limits, there are developer limits, there are all sorts of limits you can put on the system so that, to Keith's point, right, I can't have developers going in here and saying, I want 16 cores for my database, right? I hit save, and what OpenShift is going to try and do is it's like, oh, cool, he made a change to his Postgres database. Let me go redeploy that with 16 cores. And look at that, quota limit reached. I guess I don't have a database. Okay, so I have to go back and change that back. So again, you can go in and make these changes, right? You've limited, so I'm going to say 1 core. Do I have 1 core available to me? Let me see. So OpenShift sees that change. It goes, aha, I'll redeploy the database. Now, again, it's bringing down Postgres, right? It's rebuilding the pod, and it's reconnecting to the database mount point. So I'm not losing the database data at all. So keep that in mind as well. So again, it's a demo point, but again, I have full access to this. So questions, comments before I move on to my last section? I think we've talked about scalability. I can go into killing a pod if anybody's interested. Any questions or comments? Anything's open. All right. The one last thing I'll demonstrate, Andre, you kind of led into this, is the fact that you can run a copy of OpenShift on your laptop. This is known as MiniShift. It is a subset of what comes with you on the full install, but this should look vaguely familiar. This is essentially the same thing, but on my local laptop, right? So this is MiniShift running here locally. 99% of the same functionality. So as a developer, right, you know, as an infrastructure team, again, I'm taking from personal experience. You've got developers like, well, it worked on my laptop. Like, well, okay, that doesn't work. Did it work in OpenShift, right? Are you scaling it correctly in OpenShift? Are your resources set correctly? So they get a very good environment here to play with. It's got just about everything you could want. There's no monitoring out of the box, but we can add that later on. So I just wanted to show that off. That literally is a couple command lines to get this deployed, and you can size it accordingly. It's all free. It doesn't require anything of the sort. So I do want to cover just a couple of things just to reiterate for infrastructure. It gives the developers a self-service portal. No more tickets for new environments, although we can limit that, right? You can restrict developers to be able to make new projects, and it has to go through a workflow. That's possible if that's what you guys require. We were building a system at my last job to do that. Basically, you know, we wouldn't let the developers spin up new projects. They would have to submit a JIRA ticket, so there was a tracking mechanism for all of that, for an audit perspective. They're all secure. And I mentioned the breach and how OpenShift was not susceptible to that breach. You've got a lot of stuff built in. You've got load balancers built in, firewalls are built in, every one of your containers is wrapped in IP tables. Networking, there's a SD network, there's a software-defined network around all of OpenShift. Every project gets its own virtual network, similar to the cloud. And there's also storage interfaces. So if you have a NetApp or other storage properties, you can actually have it attached and create NFS mounts for your project, again, all based on permissions. We saw the limiting of resource usages. And then the other part I didn't really go into is patching the environment. So similar to like VMware, where you can vMotion everything off and go into a maintenance mode, you can do similar things in OpenShift as long as your apps are highly available. So it's not a vMotion. It kills the pods, but it brings them up on another host that is not in maintenance mode. So those kinds of things. And again, runs just about in any environment for you. And then lastly, I want to talk about the environments for Honda. I think Keith alluded to this. So the best practices for this, you could bring up 3 environments: dev, staging, and production. Although maybe in your environment you do a dev, staging, and production. Meaning, you know, dev and staging are in one environment, productions in another, and then we could, utilize the ability for developers not to have access to production, and rather the infrastructure team is the one that deploys production, and you keep those environments separate. Lastly, I guess Keith has got the POC going on, but we're happy to help you guys spin up POCs in your environment, whether that be cloud-based, on-prem, do assessments, educate you on how to do that, and lastly, managed services as well. And Andre, I'm kind of done unless there's questions.
No, thank you. I will let me stop the recording here.